This is a basic overview and review of topics 7 and 8, which was our trig topics for Algebra 2. So we're going to put trig as our review, and it's topics 7 and 8. Now just some basic ideas to help get you thinking about this, because it's been a recent chapter that we've done. When something's periodic, what you want to know is when it repeats. How long until it repeats? So if we're looking at a graph that looks like this, where we've got it going, for instance, up and down, and up and down, and then back up, so like that. Notice if we were to tell from here that this is, say, negative 3, and this out here is 20, then what we'd look at there is say, how many times does this graph repeat from that distance? Because that's 23 units, and we go 1, 2 to have it until it repeats. So what you would do for the period for this, or how long until it repeats, you take 23 total units it's covered, and you divide that by 2 times, and what you get is 11.5. So the period for that would be 11.5. Now, it might have a pi with it, it might be in degrees. This one we've left all units off, so it would be implied to be in radians. It'd be 11.5 radians. Now, amplitude is how far from the middle to the top. So for this one, we need to know how far it goes up and how far it goes down. So if you look at this and we say that this is, for instance, at, let's say it goes up to 15, and then this is, it goes down to, let's say 9, then the distance between those two, we're gonna cut it in half, because it will be halfway. If it's from the middle to the top, that's halfway from the bottom to the top. So if we look at that, the distance is going to be 15 minus 9. That's going to give us 6 units. So the amplitude here will equal 6 divided by 2, or 3 units. So halfway between 15 and 9, we just go from there to the top would be 3 units up, or 3 units down to the bottom. So it'd be 12 right in the middle if we were looking for that. All right, lastly then, how do we solve problems, okay? The first thing you do is you check to see if it has a right angle. Okay, you ask that question. If the answer is yes, you use SOHCAHTOA. Remember, SOHCAHTOA is where you have sine is the opposite side over the hypotenuse, cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent. So if you're looking at a triangle and there's a right angle in it, and this is our angle, the side opposite is over here, the side adjacent is the one next to it that is not the hypotenuse. Remember, the hypotenuse is opposite the right angle, so maybe look to see which one's the hypotenuse first, and then once we have the hypotenuse, then you can decide the one next to it is the adjacent side, the one opposite we use for SOHCAHTOA. So use that in your triangle. So if you have an angle of elevation or an angle of depression, I'm going to do the example here with an angle of depression, because that's the one that people tend to struggle with. Angle of depression of, let's say, 14 degrees, and we have this type of problem where there's something up here. Remember, angle of depression is from looking straight going down. And so we've got this angle of depression here. All right, so this would be the 14 degrees. A lot of people put it there by mistake. Don't make the mistake of putting it here. It's the angle from looking straight going down is an angle of depression. Angle of elevation would be from looking straight and going up. So this would be an angle of elevation from the bottom point. And notice because of alternate interior angles with parallel lines, the angle of elevation at the bottom is the same as the angle of depression from the top. So let's say that we know that this side here is, let's say it's a 20, and we're asked to find how far this one is, okay? That would be the same here or the same over here. You could use either one of those, but we're going to go ahead and use our trig, our right triangle trig with SOHCAHTOA. So what we're going to do is we're going to set up here, because this one is tangent, opposite over adjacent. Tangent of 14 degrees is going to equal the opposite side 20 over the adjacent side x. In order to get rid of that denominator, we're going to have to multiply by the x on both sides. That will get rid of it. So multiply by x. Whatever you have in the denominator is what you multiply on both sides to get rid of it. So now I have x times tangent of 14 degrees equals 20, because the x's cancel. And then we divide by tangent of 14 degrees. And so you get this function, and then you go ahead and do that on your calculator to get the value. So lastly, the law of sines and law of cosines for this. Law of sines, these will be given to you on the exam. The law of sines, I'm going to write out different than what we're used to seeing it. I'm going to put sine of an angle. For instance, if we put angle M over the side opposite it is equal to the sine of an angle, say Q, over the side opposite it. So if I've got a non-right triangle, so here's my triangle, and this is angle M, side M would be opposite it. And if this were angle Q, then the side opposite it would be side Q. You'd set up this ratio and solve by multiplying by the denominators to get those out of the denominator, and then simplify and solve from there. So that's the law of sines. When you use the law of sines is when you have either angle, angle, side, angle, or side, side, side. And remember, this is the ambiguous case. So you should look up and review over the ambiguous case, because that's what we would use that for. So this is the law of sines. They'll be given to you, but you've got to know when you're going to use it. Given two angles and a side, law of sines. But if you're given two sides and a non-included angle, you'll also use it as the ambiguous case. And then lastly, the law of cosines, just as a review, and you can look up videos on these to review over how these problems are done. Law of cosines, for instance, if I've got side A, that's going to equal b squared, if you square them, plus c squared minus 2 times b times c times cosine of angle A. Notice that this side is opposite that angle. So when you do these, it's got to be the side over here is the one opposite that angle there. You'll use this in the cases of when you've got a side, 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 or when you have side, angle, side. And it's always recommended that if you do not know the biggest angle in this, use law of cosines to find the largest angle. Because what that tells you is it will allow for obtuse angles. Okay, law of sines does not allow for obtuse angles. So you need to make sure that you do law of cosines to find if there's a possibility of an obtuse angle. All right, so in looking for examples on this, you can go to some of the other videos that we've done to do this. But this is how you solve the actual problems. Use SOHCAHTOA in order to do the basic ones with a right angle, and then when you don't have a right angle, use law of sines in these cases and law of cosines in these cases.